Okay, so good afternoon, everybody. Okay, I'm happy you are happy. Okay, anyway, so good afternoon, everybody. So yes, last time I started to explain how can we do branch and loop instructions in assembly. Actually, as I explained, I told you the way we are gonna do it, we have to use two instructions. Usually compare instruction or test instruction to update the flags, and then after this instruction, we use a branch instruction. Okay, so this is like a building block. So we're gonna use this building block to create statements. You already are familiar with this statement in any high level programming language, like if statement, for, while, do while, switch. We don't have all these statements in assembly. We don't have them as statements, but we can create this statement. You can even create new statement if you want using these building blocks, compare and branch instruction. And I explained last time, I explained what kind of compare instruction, test, branches. I also explained, yeah, I give you some example. I explained if statement, how can we do if statement. So I'm gonna if then else. Also I explained this one. So yeah, so last time I started to explain for loops. I'm gonna start from here. So this is, you should be familiar with for loops. As you see here, this is how we do for loops in assembly. In C language. As you know, in for loop, I use for loop if I want to make a certain number of iterations. You know what is the difference between for and while loop? Okay, you should know that's the difference. For loop is used if you want to make a certain number of iterations. Okay, so for example, I wanna make 100 iterations, 200 iterations, and so on. Okay. For example, if I have an array and I know during the programming, when I write the program, I know that this array has, for example, 200 elements, and I wanna count. I wanna do something like, for example, I wanna count how many elements are negative or positive or whatever. That means I have to scan all of them. I have to scan all of them. In this case, I have to use for loop, okay? And I have to make for 200 times in order to make 200 iterations. And in every iteration, I'm gonna work on one element. That's how it is, right? This is for. While is different. While is used, if you don't know, usually, for sure you can use while as for, or you can use for as a while, but usually while is used if you don't know how many iterations, but I want to keep looping until something happens or until condition is something. For example, I give you an example here. I'm asking you, please write a program to check, is there a zero element in this array or not? That's what I want to do. So I have an array and I want to know if is there a zero element or not. Okay, so now you need to ask yourself, do I need to make 200 iterations? No, it's not necessarily to make 200 iterations. Once I find the zero, okay, I'm gonna exit and that's it. You get what I'm saying? In this case, for sure, we can use while. Okay. Another example, if you take some numbers from the user, and when the user finishes, he has to hit a certain for the enter or escape or something like that. Okay, so I'm gonna keep taking numbers until the user hit enter. Okay, so in this case I can use also while. I don't want to elaborate here. You should have some experience in high level programming language. You should already know how for is different from while. But what I'm gonna focus now is how can you do for in assembly. Okay. Let's see how we did it in C, because we are going to use you are going to use the same way right now. Okay, so the way we did it in C language, it was something like that. In C language, number one, I have to use a variable, and this variable actually acts as a counter. Is that okay? So this one should count iterations. Iteration number 1, iteration number 2, iteration number 3, iteration. So every time I make one iteration, I have to increment this counter. And then in every iteration, I have to compare the count with how many iterations you want to make, okay? As long as the value of the counter is less than 10, so I have to keep looping. This is the main idea. That's exactly what I'm going to do right now, okay? So here I'm explaining if I want to do the same thing, so I need to get a variable. The easy way is just you can use one of the register, like for example, R0 or R1, any register, okay? And then this register, I'm going to put 0 in this register, okay? Number 2, every iteration, I'm going to increment R0, okay? You already know how to increment R0 by using add instruction. Also, every iteration, I'm going to compare R0 to this number, okay? As long as R0 is less than this number, okay? So I'm going to keep looping, okay? So here I explain different ways. To me, this is the easiest way. You can just use it. I just want to make it easy. If your problem, and tomorrow in the lab, you are going to need something like 4. So if you need 4, you can use the structure explained here. I'm not asking you to invent a new way. Just you should know if you want to do for loop, how can you do it? And I give you here example. You can just use this example. So I'm going to show you how I made it. Okay. So here, this is what I'm going to highlight now is the code needed to create for loop. So this is number 1 here. I'm going to initialize I, which is R0. I'm going to initialize it with 0, as you see here. Okay. And then, as you see here, I'm going to compare R0 to 10. As long if it is greater than or equal, so just to go outside. I'm done. Go outside. If not, if it is BGE, remember BGE means B means branch, G means greater, E means equal. So if it is greater or equal than 10, just to go outside. If not, and it's gonna come this way. And here, as you see here, I'm gonna increment I, which is R0 this way, and then I'm gonna come back here to check again and keep looping. Okay. So what I highlighted right now is actually the for loop. The instruction for loop. So you need this one here. You need actually to compare. Number 3, you need to increment here. So you can see here, I'm gonna keep looping until this condition is true. The only way, because this branch is unconditional, the only way to get out of here is just use it by this one. Okay. So where is the body? Where is the body of 4? The body of 4 is this part here. Can you add if you want to do more things, you can just add here. Okay, but this is what I need here in the body of 4. Okay, guys. So again, it is what I'm explaining here is exactly similar to what we did in C language, but the only difference is that C language we write only one instruction this way. However, here you have to write different instructions. As you see here, this is for loop. All of these are for loop. Okay, and this is the body of for loop. Any question? Is that clear? Okay, guys, you understand the logic here? So I'm going to compare R0 is the counter, it's I. I'm going to compare I to 10. If it is greater or equal, that means I already made enough number of iterations. Then I'm going to go outside. If not, I'm going to come this way to execute the body of 4 and then increment I and then go back to check again. So I'm going to, every time I come here, I'm going to go back because this one is unconditional. Any questions? Okay. I can do the same thing in a different way. Again, all of them are okay to me as long as it works. It's okay to me. So let's see here what I did here. So this one is exactly close to this one. The only difference is that here, for some reason, I wanna here. I'm gonna make the compare here. So I'm gonna compare R0 to 10. If I or R0 less than or equal 10, I'm gonna loop to here, as you see here. So in the very beginning, because you have to check in the very beginning, okay? It's in the very beginning, you have to check. That's why in the very beginning, I'm gonna jump to here to check first time. After that, I'm gonna make iterations to here, okay? So as you see here, here I'm gonna check. if the counter is equal to 10 or not, okay? So if not, I'm gonna come to here to execute the body. This is the body. This is the body of F, okay? And then after that, I'm gonna increment I, compare again, go back. Increment I, compare again, and go back. So what instructions we have here for loop? This one here. We have also this one here, okay? And this loop, okay? That's it. And the body of 4 is here. Any questions? Okay, so we can do the same thing using, as I told you before, you can use branches, conditional branches, or you can use conditionally executed instructions, okay? As I explained before. Maybe it's easier to use branches, but I'm teaching different ways. So let's see, also I can do the same thing this way. So let me explain it, okay? So again, we have here R0, which is I initialize it with 0. Also, as you see here, what I'm gonna do, I'm gonna compare R0 to 10, okay? So I'm gonna compare I to 10, and then I'm gonna say, add, this is the body. So here I'm gonna say, I wanna add R1 to R0, okay? If it is less than, so this is a conditional instruction. So if R0 less than 10, so we are gonna do this addition. And then next one also is a conditional one. I'm gonna say add if less than. So here I'm gonna increment R0, which is I, if R0 less than 10, okay? Finally, I'm gonna say if R0 is less than 10, go to loop here. You should be a little bit confused here. You know why? I'm gonna tell you why. But I wanna clarify it. Listen to me. So this one here, less than. So this one is going to use the flex of this one. That's totally fine. This one less than. This also is going to use the flex of the first one. Why? Because this instruction does not change the flex. This one doesn't change the flex. So this one is going to use the flex of the first one. This one also is going to use the flex of the first one because this one does not change the flex. You understand what I'm saying? That's why it works. However, if you say add S here, add S, is not gonna work. Why? Because this one is gonna use the flex of this one, which is not true, because I want to add 1 if R1 is less than 10, right? So I have to use the flex of this one. Very important to understand what I'm saying here, guys. So what I'm saying here, you compare R0 to 10. Here I'm gonna use the flex of this one. Here you also are gonna use the flex of this one because this one does not change the flex. Also here, this one also is going to use the flex of this one because previous instruction don't change the flex, okay? So that's why this one is going to branch if R0 less than 10. Okay, guys? Clear? Anyway, I don't want to overcomplicate it. I just want to tell you there are different ways. If you want to use this one all the time, I'm totally fine, but still I'm expecting you understand this one, okay? But you don't need, it's just a programming, right? So as long as, to me, I'm not gonna force you to program in a certain way, right? So as long as it works, I'm totally fine. Why not? It's a programming. There are different ways. Any questions? Okay. Now I'm gonna do while loop. You will see. You will see here. It's gonna be exactly the same thing. I'm gonna use compare. Also, I'm gonna use compare and the branch instructions to create something like while. So if you see here, guys. Let me first make a refresh your mind about while, how you use to while in C language. As you see here, guys, we have the keyword is while. Also here you have a condition, I greater than 0. As long as this condition is true, you are going to keep looping. How many times? I don't know, maybe 100, 200, 300, okay? So I don't know how many times. As long as the condition is true, you are going to keep looping, okay? For sure, I'm saying if you don't know the body here, so you don't know how many times, you are going to keep looping until, as long as the condition is true, you are going to keep looping. Is that okay, guys? Okay. So maybe this is not the best example because actually what I'm going to do right here, I'm going to use while to make it like 4. Okay, what I mean, I want to loop a specific number of iterations. So I'm using while as 4. Okay, but usually I'm going to use while if I don't know how many times, like for example, I give you a very clear example. I have an array. I wanna scan the elements until I find a negative element. So this can happen in the first element, can be second, third. So I don't need to continue, right? Because I just wanna check if there is a negative element or not. So I'm gonna, are you negative? No. Are you negative? No. Are you negative? Yes. So exit. I don't need to continue, right? So in this way, in this way, you have to use while. For loop is used if you want to make a certain number of iterations, regardless of anything. I'm gonna do, for example, I want to count how many zeros in the array. That means if you have a 200 elements in the array, so I have to make 200 iterations. Okay, no matter what. So it should be 200 because I have to scan all the elements. Okay, I don't need to explain that. You should have some programming experience. You should know what is the difference between while, for, and do while, as I'm gonna explain right now. Okay, so as you see here in while, guys, there is that's exactly what I'm gonna do right now. There is a condition, right? I'm gonna check this condition. If the condition is true, I'm gonna keep looping. If it is false, go out, leave. That's it. So that's exactly what I'm gonna do. So if you see here, guys, let's look at this again. Here I'm explaining different ways. Okay, so for example, let's do this one here. So where is while here? While is actually this part here. Okay, and this part. This is while. Okay, so what I did here, as you see, guys, I'm gonna check the condition. I'm gonna see if this condition is true or not. Here, I'm gonna check if the condition is false. Okay, so what I'm gonna say here, if R0 branch if R0 less than 0, less than or equal, I think this one should be, oh, no, that's okay. I think it should be okay because as long as it is greater, as long as it's okay. As long as this is a condition, as long as I is greater than 0, I have to keep looping. However, if I is less than or equal 0, that means the condition is false and I have to leave. That's exactly what I did. So what I did here, guys, I'm gonna say if R0 less than or equal 0, leave. I'm done. Go outside. I'm done. Don't keep looping. Okay. If not, that means R0 greater than 0. I'm gonna come this way, and this one is unconditional. It's gonna bring me here anyway. Okay, guys. Again, here I check the conditions. If the condition is false, leave. If not, I'm gonna go execute the body of while, and then come back again, check again. Execute the body, check back again, and so on. Any questions? Okay, I want to make it easy. So for example, I'm saying here the opposite of this condition. For example, if this condition is equal, so here I'm going to say branch if not equal. You got what I'm saying? The opposite of this condition. That's what I want to check if the condition is false. Okay. Again, this is a programming. Someone can program it in a different way. So someone can ask me why you want to check if the condition is false, you have to leave. Yes, it's going to work, but why you want to do this way? If the condition is false, leave. It's just easier way, but you can do the other way. That's just a programming, right? As long as it's going to do exactly what I want to do here, it should be okay, right? So here, I'm going to say, I find this one is an easier way. And I think I give you another way here. Here you are going to check exactly the same condition. If it is true, loop. Because look here, guys, I can do this one in two different ways, by the way. One way I'm going to say, if I greater than 0, loop. Okay, this is a logic. That's exactly what I did here. You can do it in a different way. If I is not greater than 0, it means less than or equal 0. So please exit. That's exactly the logic I used here. Okay, I can use a different logic here, as you see. Okay, so here what I did, guys, this is the while loop, this part and this part, as you see here. But for sure, in the very beginning, in the very first time, I'm gonna come to here. Okay, as you see here, guys, I'm gonna compare R0 to 0. I'm gonna say as long as R0 greater than 0, as long as this condition is true, please keep looping. Again, guys, don't be confused. I just want to explain this programming. You can do the same thing by different ways, okay? And again, As long as it works, I'm totally fine. But as an instructor, I just want to tell you there are different ways, okay? So I cannot say this one is better than this one or this one. As long as it works, it should be okay. Any questions? Okay. Again, you can do it using conditions. Sorry, you can do it using just without branches or using conditional here. So here I'm going to compare R0 to 0. I'm going to say add if greater than. So if R, that's exactly the condition here. R0 means I, okay? So I'm going to say here greater than, as long as, oh, if I is greater than 0, you have to do this addition. If here, this one and this one, okay? If I is greater than 0, you have to do this subtraction and then come back to check again. Come back if it is greater, if I greater than 0. Anyway, maybe this little bit difficult, but it's totally fine. This one is gonna use the flex of this one. This one also is gonna use the flex of this one. This one is gonna use the flex of this one. Okay, guys, any questions? Can anybody tell me what is the difference between while statement and do while statement? You should know, man. You should know it, right? Yes.
It's about when you first
Raise your voice.
It's about when you first go to the loop, do while, no matter what, it's going to do it once.
At least once.
While
Yeah.
might skip it and not do it at all.
Yeah. So the difference is very small difference. In case while loop, you check first. If the condition is true, you are going to go to the bottom. If not, you are going to leave. So in the very beginning, if the condition is false, you are not going to execute the button. You're just going to, because you check first. Do while, sometimes in programming, I need to do something like that. You have to execute it first. You execute the body first, and then you check the condition. So if the condition is false in the very beginning, you are going to at least execute it once, right? Yeah. So actually, that's what I'm going to tell you here. I'm going to do, how can you make do while? No, it's the same story, similar to what we did here. So look, you try to see this program. I'm going to do minor change in this program, okay? I'm going to just remove this instruction. It's going to be do while. So what's going to happen here, I'm going to come here, I'm going to execute the body first, then I'm going to check. If the condition is true, go back. If the condition is true, go back. If the condition is true, go back. If the condition is not true, please leave. Make sense? So now it becomes do while, not while. But if because of this instruction here, in the very beginning, when I come here, I'm going to go to check first. So in this case, this one is while loop because you check first. Any question, guys? Okay. Yeah, this is do while. That's exactly what this one is identical to this one, but just we removed this one as I explained. Also, you can do it here in a different way, as you see here. So what I did here, this program is similar to this one here, but again, I'm not gonna check first. Okay, as you see here, so I'm gonna add first. I'm gonna do addition. And then I'm going to do subtraction. This subtraction here, this one, every time you subtract I. And then after that, you have the option. If you wanna put compare here, it's okay. You can put compare if you want. But as I told you before, sometimes I don't need compare because when you do the subtraction here, this subtraction S, you are going to subtract one from R. Here, R0, you are going to subtract 1 from R0. So this one is going to update the flex, okay? So that means if R, because you need to keep looping as long as R0 is greater than 0. This one is going to update the flex, okay? That's why you can just use branch here. Again, guys, I want to make it simple. If you are confused, it's not going to hurt to add one more instruction. Yes, it's not. In the beginning, it's okay. You are learning, right? But also you have to keep in mind, sometimes we don't need to use compare. So what I want to say here, guys, you can put here an instruction. You can say compare R0 and number 1. Okay, you actually don't need it because already this instruction, it's enough to update the flex. But you are still in the beginning. If you want to do this way, that's okay. in the beginning, okay? But actually, sometimes you don't need it. You can just use this instruction because the flaps already updated here. Any questions? For sure, if you don't put S here, this one is not going to be true, right? Because no one will update the flex. This one is not going to update the flex. This one is not going to update the flex. You don't have to compare. So nobody will update the flex. So how this one will work? You understand what I'm saying? Any questions? Okay. So I just have one example here. I think I explained this program in several places before I go to switch case. So in this program, actually, as you see here, guys, we have two arrays. So we have this array of bytes, and we have array of bytes here, or a string. You know, if you have a message or you have a string, as I explained to you before, this is array of bytes, because every one is going to be stored in ASCII code, as I explained to you before. Okay. All what we want to do here, guys, we want to copy. So you actually have two arrays. I want to copy one array to another. So I have to copy element by element. You got what I'm saying? So, and now this is, and now you should ask yourself, do I need while, or I need while or for, right? So actually here, because, and this is actually one of the questions in tomorrow's lab. Okay, listen to what I want to say. Here, someone can say, okay, that's easy. I'm going to count how many. I'm going to count how many we have here. Like if we have 1, 2, 3, 4, 5, 10, 7, whatever, 30, for example. So I'm going to make for loop for 30. Is that okay? You can think this way. However, this is going to work only for this one. If I change the parameter, if I change it, so you need to go and change the program, right? So that is why there is another way that can work for any length. Okay, that is, you can just look for the delimiter. I told you every string we have to end it with a delimiter, which is 0. You got what I'm saying? And that's what I'm asking you to do, I think, in one task in tomorrow's lab. Okay. I even asked you, that means if I look for the delimiter, that means even if I change this one, still your program is going to work without doing any modification in your program. You got what I'm saying? But if you make for loop for this one, it's not going to work, or you have to change your program if the message is bigger or smaller. You understand what I'm saying? So, but if you just look for the delimiter, your program is going to work. If you put the delimiter here, I'm going to keep looping until I find the delimiter. If you put it here, I'm going to keep looping until I find it. Is that okay, guys? So that's why in tomorrow's lab, I think in one questions about passwords, you are going to store some kind of passwords. I asked you to change the array, and your program should work without even modifying it, okay? Because you are going to look for a delimiter, okay? So that's exactly what I'm going to do right now, guys. So what I'm going to do, I need, for sure, as I said before, and if you want to work on arrays, so I need a pointer here, I need a pointer here. That's okay. And you have to copy byte from here to here. So you need 2 pointers. I'm going to copy byte from here to here. Then I'm going to increment this pointer. I'm going to increment this pointer this way, right? And then you copy. And then again, you increment this pointer, you increment this pointer, and then copy again. You have to keep doing this until you find what? Until you find the delimiter. Once you find the delimiter, I'm done. Okay. So that's why I need while loop here. Let's see how I made it. Again, as we did it, as I explained to you before, you need 2 pointers, as you see here. So I have R0, R1. R1 is going to be here. R1 is going to move. It's going to move here, and you have R0 here. 2 pointers. Okay. And then as you see here, I need while loop, as you see here, guys. I'm going to compare R0 to the delimiter, which is 0. If not equal, keep looping. So here, this is actually, you are going to keep looping until you find the delimiters. Okay, guys? So if the delimiter is after 10 elements, you are gonna make 10 iterations. If the delimiter after two elements, you are gonna make 2 iterations and so on. Okay, guys? In tomorrow's lab, you need something like that. Okay, and then here you can see this is the body of while. In the body of while, I'm gonna copy a byte pointed by register 1 R1. I'm gonna copy from here for one element from this array to this array. Okay, that's exactly what I did. As you see here, guys. Number 1, I'm gonna load So I'm going to read the byte from pointed by R1, a byte, increment R1. Okay. And then I'm going to store this byte in the location pointed by R0, increment is R0. So in every iteration, I'm going to copy byte from one array to another array. Okay. And then increment is the 2 pointers. I did it this way. Any questions? Again, you have too many examples. It's the best way to understand this part is examples. Okay. Any questions? So let's, again, I'm going to give you more examples. How can I do something like a switch case? Using the building blocks. The building blocks we have are compare and differential instruction. You can even invent your own statement. You can make a new statement and then you can implement it. So that's exactly, guys, that's exactly what happened in reality. In C language, we used to use use something like do while. Hardware doesn't understand to do while. This is your language. Okay. Once you do while, something like that, the compiler is going to convert this one to this one. Now, I think this is actually what's going to be run by the machine. This is what the hardware is going to do, right? The hardware doesn't understand do while. This is your own language. You understand what I'm saying? I think it's very clear now. Any questions? That's why I need a compiler. Compiler is a translator. It's going to translate your language to the hardware language. This one. Okay, guys. Okay. Let's see how can we do switch case. Let's first make a very quick revision on what is a switch case. As you know from C language, this is how can you make a switch case. First, you have to use the keyword switch. Switch is a keyword, and you have to put here a variable. Sometimes you can put equation, doesn't matter. So you can put here a variable. And based on this value, for example, this value is 9. So I'm going to execute this part, okay? The body of case 9. If this variable is 8, so I'm going to execute the body of 8, okay? Then I'm going to do the body of 7 and so on. And you can see here, guys, so there is no way. So based on this value, so you have a score. If a score is equal to 1, I have to do something. If it is equal to 2, I have to do something else, and so on. Okay. If a score, so if a score is 9, so I'm going to do this one. If it is 8, I'm going to do this one. Okay. So actually here I wanna convert the score to a grade. Okay, C or D or F. The F here is the default. The default means anything else. You know what I'm saying? So if a score is 9, is gonna come here, 8 is gonna come here, 7 here, 6 here. If anything else from 0 until 5 is gonna come to here. Okay, guys. And also in C language, what you have to do is that in every statement here, you have to put break. Why? Because once I come execute the body of this one, I have to go outside break, because it's not allowed to execute more than one case. So once I execute one case, so I should not continue. I have to break. Okay, you have to write break. Okay. Here, what I did in the very beginning, here I did case 10 and case 9. So if it is case 10, it's gonna come here to go this way. Okay, nothing is here, but it's gonna continue until it hits break. Okay, if it is case 9, it's gonna come here, execute this one, and then go outside. Okay, this is because, as you know, if your score is 9 or 10, you are gonna get grade A. And instead of repeating, you can repeat, but there is I can copy this part here. Okay, you can do that, but just if you want to be more professional in programming, you don't know because this is repeated. This part is repeated. So I'm going to say if this is 10 or this 9, what's going to happen? It's going to come here, case 10, execute until it hits break. By the way, if you forget break, this is close to assembly. If you forget a branch, some unconditional branch to outside, if you forget this one, the code is going to go this way. You got what I'm saying? So that's why you have to put break. Any questions? How can we do the same thing in assembly? Very easy, as you will see. I'm going to, again, using compare and branch, I'm going to implement the same thing here. Okay, so as you see, look, right, guys, very easy way. Look what I'm going to do. I'm going to say compare R0 to 10. R0 here is the score. I'm assuming the score is stored on R0. I'm gonna compare R0 to 10. If it is equal, R0 is equal to 10, please go to case 10, as you see here. It's gonna come to here. Okay. Same thing, if it is case 9, go to case 9. If it is case 8, if it is equal to 8, go to a label. Again, this is just names, guys. It can be any name, but for sure, I'm gonna use some. I am not gonna confuse myself. The machine doesn't understand. So case here, the word case here is different from case here. Case here is a keyword, is a part of the instruction. Here, case, just a label, any label. Okay. So anyway, so same thing. I'm gonna. So if R0 is 10, so I'm gonna jump to here. If it is 9, I'm gonna jump to here. If it is 8, I'm gonna jump to here. If it is 7, I'm gonna jump to here. If it is 6, I'm gonna jump to here. If it is none, if it is not this one, not this one, not this one, not this one, so here I can put default here. And in the default, I'm gonna do something, and then I'm gonna say branch exit. This is like exit, just a branch to outside. Same thing here. In the body of 9, I'm gonna say, as you see here, just store A in R1 and then go outside. This is like a break, go outside. If it is in case of 8, I have to do something here, whatever you wanna do. Here, what I'm doing here, I'm storing the ASCII of B in R1 and then go outside. If it is 7, I have to do something and go outside and so on. Okay, guys, any questions? Questions? Okay. So I think the last thing I have here, guys, also in C language, we have something called if, else if. You remember if, else if? I'm gonna explain how it works. As you see here, guys, if R0, here just a name, it can be any name because it's not as simple. This is C, a variable. Okay, maybe I confused you when I say R0. Some, any variable, I, anyone. Okay, so don't be confused. I, okay, anyway. So if variable I is less than 0, so I'm going to execute the body, this body, and then go outside. Okay. If not, if the first condition is false, so I'm going to check the second condition. If I greater than 5, so I'm going to execute this one and then go outside. Okay. If not, so I'm going to check the next condition. If the next condition is true, so I'm gonna execute the body and then go outside. If none of this condition, none of them is true, so I'm gonna execute else. Okay, this is how else if statement works in any high-level programming. There is no way you can execute two bodies at the same time. There is no way. Only one body is executed. Okay, only one. Okay. If none of this condition is true, so I'm gonna execute else. Again, how can we do the same thing using assembly? Just look how I made it, guys. Here, I'm gonna compare R0 to 10. Okay, so here I'm just mapping whatever I did here. So I'm gonna compare R0 to 10. Okay, if it is false, if this condition is false, what should I do if it is false? I have to come here to check the second condition. That's exactly what I did. As you see here, guys, I'm gonna say if the first condition is false, here it is less. Here I'm going to say greater than or equal. So it is not less, which is greater than or equal. So if R0 is greater than or equal 10, that means the first condition is false. Please go to check the second one. Okay. Again, here I'm going to check the second condition. I'm going to check if it is false. If the second condition is false, that means R0 is less than or equal 5. So here, if it is less than or equal 5, you have to come to here, right? Here, this one is not equal. So here, I'm going to look for equal. If it is equal, please go to else. Okay. So here is the first one. I'm going to check if the condition is false. Please go check the second one. If it is false, go check the second one. If it is false, go to check go to else because I'm done. Now, what if it is true? Okay. So what happens is that here, I'm going to come this way. If R0 less than 10. However, if R0 greater than or equal 10, it's going to come this way. So the first condition here is true. So if the first condition is true, so I'm going to execute the body, this body, I'm going to execute it. And then don't forget this one. Very important, very serious. Don't forget this one. So once I execute one body, so I have to leave. I have to leave. If you forget this one, again, it's gonna come this way. Then execute all of them, no matter what. Okay, so as long as one condition is true, you have to execute the body and then don't forget to go outside. If this condition, if this second condition is true, I'm gonna come here and then go outside and so on. Any question, guys? Okay, great. So the last instruction I have here, just a very simple instruction. What happened here, you know, we use compare and branch, two different instructions. One compare, one branch. They made one instruction here to combine compare and branch together in one instruction. Okay. Anyway, but here you compare to 0 all the time. So here, what I'm explaining right now, guys, an instruction that this instruction is going to compare to 0 all the time, and then it's going to branch or not, if equal or not equal. That's exactly what I'm saying. Look here, guys. We have here compare. This is compare and branch if 0. 0 means if it is equal. If 0 is equal, right? If it is 0 means if it is equal, that means yeah. So this one is actually equivalent to these two together. I can say compare this one to 0, right? And the branch if equal. Okay. So if Rn, if whatever this R is, if Rn is equal to 0, you branch. Compare and branch together. So we have two of them. One for equal, or one if it is 0, the other one if it is not 0. Okay. So let me give you example to understand how it is. Just again, nothing here is new, guys. The only thing, instead of using two instruction here, I can just use one instruction. So exactly just less number of instructions. Okay. So in this program, I have to write here what this program is doing, and I already updated it. But anyway, so this program, you have an array of strings. So for example, you have hello, HELLO, and at the end you have a delimiter, right? So I want to write a program to count how many elements we have here. I want to count how many elements. So I have to keep looping until I find the delimiter. Okay. In every iteration, I should have a counter. In every iteration, I have to increment the counter by 1. So I need to know how many characters we have here in this array. So I'm going to start from the very beginning. Are you 0? No. Increment the counter. Go to next one. Are you 0? No. Increment the counter. I have to keep doing this one until I find the delimiter, which is 0. That's exactly what I did. So as you see here, guys, we have an array. R1, R0 is pointing. R0 is pointing at the beginning of the array. Okay, and the length, which is how many elements we have. For that, I'm going to use R1. Okay, so in every iteration, if I don't find 0, I'm going to increment R1. I'm going to show you how I made it. So as you see here, guys, first I'm gonna read the element pointed by R0. So I'm going to read this element here. I put it in R2, and then I'm going to compare R2 to 0. I'm going to say compare R2 to 0. If it is not 0, if this one is not 0, so I have to come here. So I'm going to come to here if the element is not 0. So what should I do if the element is not 0? You have to do two things. I'm going to increment R1, which is the length. Okay. Also, I have to increment R0 because and then go back to repeat again. Okay, guys. So again, here R0 is pointing at the first location. I'm going to read this byte here. Here you read the byte. Number 2, I'm going to compare this byte to 0. Okay, if it is not 0, please come to here. Okay. Okay, so this element is not 0. So I have to increment the pointer for the next iteration. I have to work on in the other element, in the next element, in the next iteration. Also, I have to increment this counter, the length or counter. Okay, I'm going to increment it by 1, then go back again. So I'm going to keep looping until I find 0. If the element is 0, this branch, so what's going to happen here, guys? Look here. I'm gonna say here, I'm gonna compare the element, if the element does not equal 0. So I'm gonna come to here. But if the element is 0, I'm gonna come here so that I exit. So I'm done. Any question, guys? I think we had a lot of examples. Again, the best way to study this section, number one, you should understand the instructions we have, because these are the building blocks. Building blocks I'm gonna use to create different statements, and then go to the statements, try to understand them. Okay, again, what's really important, I don't want to complicate things. So what's important is that if you, like tomorrow, if you need for loop, okay, you can use one of the for loops we have, right? Just use it. Or if you need to while loop, you can use while loop. I already explained how to create. I'm not asking you to invent a new way for while loop. Just understand it and use the way. Okay. Any questions? Now the last section we have here is about stack and subroutines, right? I'm gonna start with stack first. Okay. So I'm gonna explain what is a stack and how we need it, why it is important, and so on. After that, I'm gonna go to how can we make subroutines. Okay. And this will be the end of the assembly instruction we have. The last thing now I'm gonna explain how we make subroutines. And you know, in any programming language, we have something we call it subroutine or functions in any programming language. It's the same thing here in assembly. So let's come to stack. So what is a stack? What's the meaning of a stack? Okay, a stack means it's a part of the memory. It's a memory, right? But the way what we use memory for what? We use memory to read or write, right? You store data in memory to read or write. Is that right? So you read from memory, you write to memory. A storage unit, right? Memory is a storage unit. You read or write. The way you read or write from memory until now, what we did is we can call it random access. That's what we did so far, random access. What do you mean by random access? That means I can read location number 2000, and then I can go to read location number 7000. There is no specific way. Okay, I can read random. I can read any location random. I didn't tell you to read the location number 2004, you have to read to 2003, 2000. There is no specific way, random, right? So you can access any location randomly, okay? There is no specific way. That's what we did so far, okay? All what you have to do, just put the address in R0 and just read it. Use this way. That's what we have done, okay? Stack is memory. That means, again, it's just a bunch of bytes or words. You have some data stored in memory. However, the main difference between the way we used memory before and the way we are going to use it right now in a stack is how can you read or write? This is the only difference. Okay? You cannot read a stack randomly. No. If you want to read, there is a specific location. You have to read from this location. If you want to write, there is a specific location. You have to write to this location. It's not randomly, no. And this location, we call it the top of the stack. So if this is the memory, there is a specific location. If you want to read, you have to read the word there. If you want to write, you have to write on this one. Right? The idea here, guys, is very similar if you have a stack of plates, as you see here. If you have a stack of plates, if you want to take one plate, it doesn't make sense to take one of these plates, right? It doesn't make sense. So you have the top here. This is like the top of the stack. So if you want to take one plate, so you have to take this one. If you want to add one plate, you have to put on top of this one. So there is only one point or one location where you have to add or you read from this location. Is that okay? For sure, you can think a plate here like a word, 4 bytes, a word. So you can, it's the same thing. So here we have words. Okay. So I have here, I got these boxes here just to, yeah. So to show you, for example, if this is, for example, imagine every box here is like a word. Okay, so this is a word, and we have something, a pointer. For sure, we used pointers in this course all the time, right? So you should PC program counter was a pointer, right? Even if you want to read array, you have to use a pointer. You have to put the address in a register, and then you have to use a register. It's exactly the same thing. But this time we have a new pointer. We call it a stack pointer, SP. If you go to the beginning of this course, when I told you we have what registers we had a register. It's called the stack pointer register. It's exactly like PC program counter, but PC is gonna point at the instruction. Okay, a stack pointer is gonna point at the beginning or at the top of the stack. Okay, I told you at this time I'm not gonna talk too much about stack pointer because I'm gonna explain later in details, because this is not a general purpose register. This register is used only for a specific functionality, only for a stack. Okay, so anyway, assume the stack pointer is here. So this is the top of the stack. Is that okay? So if I want to add one element, so I have to add it on the top. Okay, so I have to add this one, and then I have to update the stack pointer. Is that okay? If I want to add one more element, so I have to add it here, and the stack pointer is here. Okay. If I want to read, so I have to read this one, and also I have to update the stack pointer. So every time you write or read, the stack pointer should be updated. The stack pointer is storing the address of the top of the stack. And the top of the stack should tell me this is the location where I can write or where I can read from only one point. You read or write only from one point. Is that okay? And because of the way you are going to use it, we have one point. I'm going to write here, and then I'm going to read from here as well. Okay, for example, look, this box, okay, is every box here is a word, right? For locations in the memory, a word. So stack pointer is here. Okay, so I'm going to add this one here, and now this one is here. Okay, now I wrote one word. If I want to read, so I'm going to read this one. So last in, first output. Make sense? Because again, I'm going to do it again. You have some data here. Okay, the stack is here. Then I'm going to write. When I write, I'm going to put this one here. So this is last in. When I read, I'm gonna get this one first. So last in, first output. This is what a stack is. Okay. So stack is a storage unit, or it's like memory. It's a part of the memory, but I'm gonna read or write from a stack in a certain way. What do you mean by certain way? I have a stack pointer, so in a specific location. If I want to write, you have to write to this location. If you want to read, you have to read from this location. That is why it's last in. So the last word you write to the stack is actually the first word you are going to get it from the stack. Okay. For example, if I write in the stack something like A, and then B, and then C. So this is number 1, number 2, number 3, and the stack pointer is here. Okay. So when I read, I'm going to read C, and then B, and then A. Last in, first output. Okay. Anyway, maybe someone already in other process explain what is a stack, because anyway, so this is the main idea of a stack. So a stack is just a part of the memory, but the way you are going to read or write is different from what we did before. Okay. What we did before, you have to tell me, you have to give me address, right? That's what we did before. You have to tell me which location you want to read or write. In case of a stack, you don't need to tell me which location, because if you want to read, you have to read the location pointed by the stack pointer. If you want to write, I'm gonna write to this location. However, in the very beginning of your program, you have to initialize the stack pointer. Maybe this is the only time you are gonna write to the stack pointer. After that, everything is gonna done automatically once you read or write. So you have to initialize the stack pointer in the very beginning of your program. By the way, if you want to write to the stack, write to the, again, guys, it's not difficult. What I'm explaining here, there's no big difference between when you write to the stack, you actually write a word. You write a word in memory. That's what we have been doing since the beginning of this course. Okay, you have a memory, you write a word, you read a word. Okay, so here you write a word, or when you read, you actually read a word from memory. So, so now you should understand the memory, your memory now, you have one part of the memory, it's used to store your code. We have one part of the memory, it is used to store your data. Also, you have one part of the memory is used to store for stack. Is that okay? So now I'm going to divide the memory between these three main things. Okay. By the way, when you write to the stack, we call it, I'm not gonna say write again. It's writing. You write to memory, right? That's true. But we use the term push. Okay, guys. So when I say we push, that means we write to the stack. Okay. When you read from the stack, we use the word pop. So I'm not gonna use read or write again. I'm gonna say push or pop. Okay. Any questions? You should be curious to know, okay, that looks crazy. So why last in first output? What application? For sure, it has been done for a purpose, right? It's not random. We did that for a purpose. In some application, I need something last in first output, right? I'm gonna give you more details, but we did it on purpose, right? We need something like last in first output. Okay, I'm gonna for sure give you more details. Any question, guys? Yes.
Remember 1310 with our stack functions. We had push and pop. There was also, I think it was called peek, where you could read the word but not take it off. So do we not use a function like that where you can read it without removing it here? Yeah. So we have you have something like peek. Peek you are gonna read but without removing it, right? Yeah. We don't have this instruction. We have push and pop, okay? But what you can do, you can do it, right? But it's not using one instruction. You can pop, right? Take it, store it in register X, register 2, register 3, put it anywhere, and then you push. You got what I'm saying? So read and then push, right? So yes, we don't have something like that because we don't need to peek here. Usually, most of the time, we need push or pop. Or pop. That's what we need, right? But still, you can do it if you want, but you have to use 2 instructions. Okay? Thanks. Anyway, so one of the things, guys, here. So as I told you, in the very beginning of your program, you have to initialize the stack pointer. And actually, you don't need to do that because you remember in every lab, okay? There are some instructions above your code, right? If your code is here, there are some instructions before it. And I told you this instruction for initialization, okay? They initialize memory, they initialize register. So they do a lot of initialization for the hardware. For sure we are using simulator, but in the future it's going to be hardware, or maybe just starting from next, not this lab, next one, we're going to use the board. Before I forget, please go to the department, the ECE department, and check out the board, please, okay? Anyway, so, because we're not going to use simulator anymore, just tomorrow, okay, last time. So, in the very beginning, in the initialization, you have to store the beginning address here in the stack pointer. You have to initialize it. Okay. Now, what happens here in our processor, what happens is that if you start, this is the memory, as you see here, we start from 0, 0, 0, and then we go all the way until FFF, okay? As you know, this is our memory. However, if you put the stack pointer here, if you put your stack pointer here, actually the stack pointer is gonna grow this way to the lower address. It's gonna shrink this way. Some processors are doing the opposite. It doesn't matter, okay? But I'm just, maybe don't be surprised. It doesn't matter, right? So in some processor, if I start, for example, 700 or 7,000, whatever, every time you push, you are gonna go this way, okay? But here is gonna be go to the lower address. So maybe let me. So for example, if I'm here, if I'm here, what I explained, we have to increase, assuming FF is here, 0, 0 is here, right? So what I explained, if here and I want to push, so I have to come to here. This is not our case, okay? Our case is the opposite. So here, if I'm here and I want to push, so I have to decrement the stack pointer, not increment. right? Again, so it's going to be here. So the top is here, not here. Again, it doesn't matter. Okay, some processors do it this way. So again, the top is here. So stack pointer is here. The top of the stack is here. Okay, not here. Should be the bottom. It's not. It's physical as address. It's the lowest address, but this is the top of the stack. Anyway, so every time here, I have to decrement the stack pointer, and then right here. Go this way. Okay. Again, some processor, it's other way. So here, what we do here, once you start from a certain place, if you want, for example, let me give you a specific example. So I'm gonna start from here, for example, 200,004. Okay. So and I wanna write. So what's gonna happen here? First, I have to move it to a new location here, which is at how many zeros? Yeah, I think I'm okay. 0, 0, 0, 0, 0, 0, 0. Okay, so I have to decrement to 4, and then I have to add the new information here. That's how I push. So every time if you want to push, you have to decrement. Why you are decremented? To go to a new location. I'm going to decrement in order to go to an empty new location, and then I'm going to write from there. Okay, if you wanna read or if you wanna pub, I'm gonna read the word at this location, and then I have to increment to 4. Okay, again. Some processors do the opposite, but it's okay. It's like little Indian, big Indian. So some processors do this way, that way. It should be okay. Okay. Anyway. Okay. So now I'm gonna teach what instruction we have. Yes, sure. Okay. That's a very good question. Okay, so I'm gonna the best way to answer this question. Let me ask you a question. Okay, if you have an array, okay, that's what we did before. Okay, I'm gonna create an array with 3 elements. Okay, so one element, element number 0, element number 1, element number 2. Is that okay? So how many elements you have in your array? I have 3, right? So and then you want to read these elements. What should you do in your program? That's what we have done. Okay. What I have to do, R0 has to be here. Is that right? I'm going to read this element, and then I have to add 4 to R0. I have to read this element, and then you have to add 4 to this one and read this one. That's what we do, right? What happens if my array has 3 elements, but I'm going to read 10 elements? What's going to happen? What do you think? You understand what I'm saying? So my array should have 3 elements. I have to read, if I want to read the array, so I have to make for loop for 3 times, right? Because I'm gonna read 3 elements. Is that okay? But I'm not gonna do that. I'm gonna read 10 elements instead of 3. What would happen? No, this hardware, man, they don't have the logic. There is no operating system. It's a very simple system. You understand what I'm saying? There is no operating system. There is no compiler. No one is going to check after you. It's low level programming language, man. You know what I'm saying? You don't have a compiler. It's a completely different story. So what's going to happen is that if, again, the memory has some values here. So if you go here more, you are going to read some values, whatever in the memory. Random places. It may be a variable, whatever there is. Hardware is going to give it to you, right? We don't have a compiler. It's not high level programming language. It's going to give you error. It's going to tell you out of range. You understand what I'm saying? It's low level. You are asking the hardware to give you this value. The hardware will do it. It's your fault. It's not the hardware fault. You know what I'm saying? So now, what should you do now? When you write your program, you have to make sure if your array has 10 elements, so I have to read 10 elements. If your array has 3 elements, I should read 3 elements. It's the same thing for a stack. You understand what I'm saying? Same thing for a stack. If you're a stack, so the question here, by the way, maybe I have to say the question first. So for example, assume this is a stack. So here in the stack, assume we have three elements in the stack. What if I want to read more? Okay. Again, this is your fault as a programmer, right? You have to make sure you should not read more. Okay. However, if you read more, hardware is going to give you whatever store is there. Okay. So for example, if I push if I push for 3 values, you cannot pop more than 3, right? But you're not going to get error. It's going to give you whatever in the memory. You're asking to read whatever in the memory. You get what I'm saying? Anyway. So this something should be done or considered by the programmer. Anyway, so now let's see what we have only 2 instructions, only 2. One is push, the other one is pop. And the way you are gonna write it here, guys, as you see, you can write the word push, and then here you can put not only 1 register, you can put 1 or more, but you have to use braces this way. So for example, here I'm giving you one example. If you want to push only 1 register, okay? If I want to push only 1 register, R0, it has to be this way. So if you do something like that, so whatever in R0 is going to be stored in memory. You copy. This instruction is not going to change R0. You copy whatever is there and put it in the stack. How this one works? It should work this way, guys. If the stack pointer is here, this is again, these are 4 bytes. Okay, if the stack pointer is here, every time you want to add to the stack, you have to decrement, not add, decrement. So the stack pointer has to move to here, to an empty place, and then it has to store the value of R0 there. So as you see here, when you write push R0, so this instruction actually is going to do 2 things. It's going to decrement the pointer, stack pointer, the pointer is going to decrement to point to a new location, and then it's going to store the value, whatever is stored in R0 is going to store it in this location. Okay. What pop is going to do? Pop, as you see here, when I say pop R1, what this instruction is going to do? It means I want to read 1 word. I want to read 1 word from the top of the stack, and I have to store it in R1. So this one is going to change R1. Whatever in the top of the stack is going to be stored in R1. So what's going to happen here? Whatever here at the top of the stack, as you see here, this actually is this instruction is going to do 2 things. I'm going to read the word pointed by SP. So I'm going to read the word from this location. I'm going to store it in R1, and then I'm going to increment the stack pointer by 4. Okay. So increment by 4, so that, for example, you have other words here. For example, I'm going to call this word A, this word B, this word is C. Okay. Maybe I have to, yeah. So here, what's going to happen? I'm gonna read this one. Okay. I think this one should be here in the beginning address. Always, if you have a word, you have to put here in the beginning address. Okay. So stack pointer is here. So what happens if I do pop here? I'm gonna read the word pointed by the stack pointer, which is A, and then I'm gonna increment the stack pointer by 4, so that I come here. So my stack became here. So every time I wanna write, I'm gonna write here. If you wanna read, it's gonna go this way. Any question, guys? So again, this is how can you copy a push and pop this way. Push is gonna decrement by 4 in order to point at empty new location, and then it's gonna store R0 in this location. Pop here, this one actually is gonna read the word from the location pointed by stack pointer, and then add 4 to the stack pointer. Is that okay? That is how a stack pointer is gonna grow this way. Every time I add something to the stack, it's gonna be you decrement. Here is the lower address 0, 0, and this is the highest address FFF. So I'm gonna grow. If I start from here, so I'm gonna grow this way. And then it's gonna shrink this way. Every time you pop, you shrink. Okay. So if your stack is empty, you should not do pop. But if you do, it's gonna give you whatever's there. You are reading memory. So anyway, any questions? Okay. So here I'm gonna show you how can you use the same instruction, but in this case, I can push more than 1 register. I can pop more than 1 register. So it can be 1 or more. Okay. So for example, if I do something like that, I say push R6, R7, R8. Okay. So what this one is gonna do? This one is gonna push 3 registers to the stack. 3. Okay. So this one is actually equivalent to 3 instructions. But there is a trick here. there is a trick. The trick is you may think the order here, it doesn't matter. The order does not matter. You may think I'm gonna put this one first, second, third. No, the order doesn't matter. Always we're gonna push the highest value you have. Okay, for example, if it is for example, I'm gonna put here R8 here, R6 here, R7 here. It doesn't matter. Always the R that has the highest value, okay, is gonna be pushed first, regardless. So the order, so if you do R6, 7, 8, it's the same if you do 8, 7, 6. It doesn't matter, the order here. Always the one that has the highest number is gonna be pushed first, and then the next one, then the next one. Is that clear, guys? Okay. If you do pop, pop is the same thing. You can do something like that. However, the way you are here, you push the highest number first. So this one, 1, 2, 3, right? So the highest number first. In case of pop, you are gonna pop the lowest number first. So this one, I'm gonna, as you see here, guys, I think this is a very good example. Okay, here. So I'm gonna take one number. I put it this one number now, smallest number 6, and then 7 and 8, as you see here. Okay, guys. So again, it doesn't matter if you say R6, 6, 7, 8, or you say 8, 7, 6, or you say R6, R8, R7. All of that doesn't matter, right? The order doesn't matter. Always the highest rank or the highest number are gonna be first. Okay, guys. So I want you to think a little bit. If I push these values and then I pop these values, what's gonna happen to the registers? Are they gonna get their original values, or you are gonna change the values of the register? Okay. As you see here, guys, listen to me. That's very important. Look here. What I did, I'm gonna push this one here. I'm gonna push R8, the value of R8, right? Then I'm gonna push the value of R7, and then I'm gonna push the value of R6. Maybe I'm doing it the wrong way. I'm sorry. I used usually, if you wanna push, you go up. Here, if you wanna push, you have to go down. But anyway, so what's gonna happen? Here, you push R8 first, right? Then, and this is the top of the stack. Once you do another push for R7, so I'm gonna push the value of R7. This is the top of the stack. And then I'm gonna push R6, and this is the top of the stack. Is that okay? Now, what's gonna happen, I'm gonna take whatever at the top of the stack, I'm gonna put in R6. So R6 is gonna take its original value back. And then I'm gonna take R7, I put it in R7. And then I'm gonna take R8, I put it in R8. You got what I'm saying? So what I'm saying, if I push 3 register and then I'm gonna pop them, I'm gonna pop them back, even if you change the order, because the order doesn't matter, okay? Every register is gonna get the initial value back. You got what I'm saying? How? Tell me why you wanna store the values and then get the same values back. So every register is gonna take its original value back. Why? This is one of the uses of the stack. One of the uses of the stack. I'm gonna tell you why. Look here, guys. We don't have many registers. Okay? Assume I have some values here. I have some value in R6, R7, R8. And now for some reason, I wanna use R6, R7, R8. I wanna use this register to do something, okay? However, these initial values, I need them later. I don't want to lose them. I need them later. You understand what I'm saying? So now, register R6, 7, 8, they are storing some values. And then I wanna use them to do something. But these values, I don't want to lose them. I need them later. Stack can help you to do that. How? All what I'm gonna do, I'm gonna put this push here. You can modify them, and then I'm gonna put this pop here to get the initial value back when you need them. You understand what I'm saying? So you have 3 registers. They are storing some values. I wanna use the registers, but I need these values later. So what I can do, I can store the values in stack using push, and then I can modify registers, use them. When you are done and you want to use the initial value stack, you can pop them here. This is one of the uses of the stack. Okay. Any questions? Okay, I have a numerical here. I have a numerical example here, just to understand what I want to say. For example, when I say push R3, R1, R7, R2, I told you the order doesn't matter. Always, we are gonna do R1. I think which one I forgot. We do the highest. We do the biggest one first. So here R7 will be pushed first, no matter where the order doesn't matter. And then this one is 2, this one is 3, this one is 4. A stack pointer is here. Okay, so what's gonna happen? Just give me 1 minute. Okay, I just want to finish this part. Just 1 minute. A stack pointer is here. Okay, what's gonna happen? As you see here, guys, I'm gonna here every block here is 4 bytes. It's a word. Okay, but I just put it in one block to make it easy. Okay? So what's gonna happen? I'm gonna decrement by 4 and then write R7. Decrement by 4 and then put R3, R2, and R1. And now this is the top of the stack. Okay, guys. In case of pop, I told you in case of pop, what happens is that I'm gonna take, this is a stack. I'm assuming this is my stack here. This is the stack. I told you here, what's gonna happen? You are gonna, this is the top of the stack. Every time you write, it's gonna go this way. Every time you pop, you are gonna go this way, okay? So now, how many, here I need 4. So I'm gonna take this one, 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 and the stack pointer should be here at 16. So that's exactly what happened because I need 4. So I'm gonna get 4, 1, 2, 3, 4, and then the stack, new value for the stack pointer is gonna be here. So the question is that, okay, now you have 4 and you have 4 registers. So how I'm gonna put it? I told you before, the lowest one, this one will be first. So here, the first value 0, 0 is gonna come here. Okay, because the first value you are gonna get is gonna go to R1, then R2, and then R3, then R7. Okay, that's why you see the values. Okay, guys. The last thing I have, and I already explained. I just wanna, that's exactly what I explained right now, guys. If you have 4 registers, if you have 3 registers, R4, 5, 6, and you push them, and then you pop them. So they are gonna get the initial value back. That's exactly what I explained right now. Okay. So you can write here whatever you wanna write. You can use R4, 5, 6, and then you can get the initial value back. Is that okay? So what I'm saying here in this example, if you have, that's exactly what I have just explained right now. If you have 3 registers, if you push their values, and then if you need the initial values back, you have to use this one. Okay. Also, what I'm saying, you can, if you want to use this one, it's okay, or you can use 3. It's still okay. So if you want to do this way or that way, or if you do this way or this way, okay. However, there's something very, this is the last thing I'm going to explain. There is something very serious here, okay? That, look at the order, very important. Look here. Here you push 6, 5, 4. Here you don't need to worry about it because the instruction itself is going to do it. But let's see here. Here you have to pop. The order here has to be the opposite order. So here you push 4, 6, okay, and then 4, 5, and then 4. So when I take, if I want to take the same values, I have to take 4, 5, 6. So it has to be the opposite order. So if you push here, because it's last in first out. So if you want to take the same values back, the same values. So if you push 6, 5, 4, when you pop, you have to pop 4, 5, 6. So that every register, if you do this way, every register is going to take its own value back. Any questions? Okay, that's enough for today.